Well, so welcome you all to the next interactive session. So in the last video what we had seen that how basically we are going to have that KVL and KCL for a given arrangement and how I could apply this Kirchhoff's current law in a particular circuit. Now continuing the discussion further, what now we are going to discuss that how basically we are going to apply this Kirchhoff's voltage law in the arrangement what we had discussed previously. I will be taking the same arrangement and we are trying to demonstrate how basically we are going to apply this Kirchhoff's voltage law to find out the current through RL. So in this Kirchhoff's voltage law, it is the mesh analysis. So we have to consider the mesh or loop. What are they? So if you could think of, there can be two possible loop. One can be this one, another can be this one, another can be outside also. But for the sake of simplicity, I am assuming these two mesh. One is this and one is this. And now what we have to assume, some loop current. So that would be, let us suppose I1, this is suppose I2. Now what about the direction? So conventionally it should be something like this one. The direction would be in the clockwise direction for both the loop, that is the convention. If you are not taking that, it's also possible, but generally this is the convention that this I1 and I2 or whatever the loop current we are going to take, they should be in the same direction and that is generally taken in the clockwise direction. Okay. Now let us try to understand what is going to happen when this I1 is actually flowing through this loop 1. So when this I1 is passing, so the voltage drop across this should be something like that. This point will be positive, this should be negative. For R2, what about the current? Some I1 is going from top to bottom, I2 is going from bottom to top. So the net difference, that is I1 minus I2, if I could say, that is coming from top to bottom. So in that case, this point would be plus, this point would be minus. Now coming to the second loop, since the current is flowing in this direction, so this point would be plus, this would be minus, this point would be plus, this point would be minus. And if I am assuming the other one, means if I am assuming that I2 is greater than, so I could say that the current through R2 would be I2 minus I1. Previously I take I1 minus I2, so it was from top to bottom. Now we have to assume that the current would be from bottom to top because I2 is in that direction. So in that case, this point would be plus and this point would be minus. Now I had done some calculation there and based on that actually we are going to derive that what is the resultant expression what we are going to get. Now come to this first loop. What is happening there? This V1 is the voltage source which is there. So the current is coming out of the voltage source. So I will be taking it to be positive V1. That should be equal to voltage across this. That would be I1 into R1. Plus voltage drop across this one. So what is the current? That would become I1 minus I2. I'd assume that the current is passing from top to bottom, so it would be I1 minus I2 into R2. And see that source. In that source, what is happening? That the current is entering from the positive side. So that is not the case, so it would be minus V2. Or I could say it would be plus V2. See the potential. Current would be entering at the positive, so I am taking it positive. So if I could do it here, it would become V1 minus V2 should be equal to I1 R1 plus R2 minus I2 R2. We would be getting something like that. Okay, and let me be having some equation, that is equation number 1. Now coming to the second loop, this is basically what? This is basically the KVL equation for loop 1. So which one is the loop 1? This is the loop 1. Now we are going to apply this KVL for loop 2. Now you could see here we are having only one voltage source V2 there. Current we are assuming I2 is in this direction, it is higher. So current is coming out of V2. So in that case what is going to happen? That V2 will be equal to voltage drop across this. This should be I2 minus I1, because I am assuming that the direction is now coming out of this V2. So this one will be positive, this one negative. So it will be I2 minus I1 into R2 plus I2 into R3 plus I2 into RL. So compositely I could say it R3 plus RL. Now simplifying that, what we are getting? Minus I1 R3 plus I2 R2 plus R3 plus RL. Would be getting something like that. So give it equation number 2. So we are having two equation number 1 and 2. They are basically linear equation in two variable. We are having I1 and I2. So we are having linear equation in two variable, because for a given problem V1, V2, R1, R2, R3, RL would be given. So we are having two equation, we are having two variable. So solving the equation 1 and 2, we can find out what is the value of I1, what is the value of I2, we can get. If we are going to get, and what our objective, we have to find out the current through RL. So it's visible that I2 is basically the current what is actually passing through RL. So basically whatever I2 we are be getting, that would be the value of current that is passing through RL. Now here I would be adding one more point, that in case this I2 is coming to be negative, it might be. In the latter example, we would be coming across that actually. If I2 is coming to be negative, then what it actually implies? If anyone, I1 or I2, if any of the two is coming to be negative, that implies that the direction of current what we had assumed is wrong. So if suppose I1 is positive, I2 is negative, this implies I1 will be in this direction, I2 will be in this direction. Or in other way around, if I am taking that no, I2 is positive, I1 is negative, so it means I2 will be in this direction and I1 will be in this direction. Okay, so that is what the thing is. Now this is what the traditional method is saying. Now if we are going to think a bit different, we are coming out of the box, that no, I am not going to follow traditional method. What I am assuming, that a current is actually the loop current I am following. One is in this direction, another is in this direction. Let us suppose I am assuming V2 is more powerful, so it is driving a current I1 in the counterclockwise direction in the first loop and I2 current in the second loop in the clockwise direction. Let us assume that. Then what is going to happen? Now what about the voltage drop now? For this first loop, this point would be plus, this point would be minus. If I am assuming that I1 is flowing in this direction, in R1 the potential drop would be this, plus this should be minus. Now for the second one, it would be as it is, what I had done previously. And what about the current that would be passing through R2? So you could see I1 and I2 both are from bottom to top. So the current through R2 would be I1 plus I2. It was not I1 minus I2 or I2 minus I1 what we had done in this particular case. So let's see how to handle this situation now. Now if I'm going to write the KVL equation for loop 1, what is going to happen now? Just try to think. What we are having, the current is getting out of V2. So I could say the source is V2. That should be equal to plus minus plus minus plus minus. So it would be I1 plus I2 into R2. This is basically voltage drop across this resistance plus voltage drop across this. So it would be I1 R1 plus V1. So let me simplify this one. Should become V2 minus V1 should be equal to I1 R1 plus R2 plus I2 R2. This is what we are going to get. Now let us compare this and this. Equation number 1, and let me call it equation number 1a. So let us compare the two. So what we are going to get, that if I am going to multiply both sides by minus, so what is going to happen? Let me do it in a separate page, otherwise you couldn't code that. What we can write, if I am adding minus to both sides, so we can write V1 minus V2. This is in equation 1a. That should be equal to minus I1 R1 plus R2 minus I2 R2. This is going to happen. Now compare this equation and this equation. V1 minus V2, V1 minus V2. They are same. Minus I2 R2 minus I2 R2. Same. What is actually happening? That this minus sign is coming in I1, which is not available here. Why it is so? Because the direction of I1, what we have assumed here, is opposite to that of this one. And this is what I am talking about. If you are going to have the convention right, that what is the voltage drop and how we should follow, that automatically that minus sign would be coming over here due to this opposite direction of current. And this is what you have to understand it in a proper way. Now coming to the loop 2 in this case. So KVL equation for loop 2. So what is happening? The current is coming out of V2. So I can write V2 would be equal to I1 plus I2 into R2 plus I2 into R3 plus RL. So simplifying that, what I could write, V2 would be equal to I1 R2 plus I2 R2 plus R3 plus RL. This is equation number, say, 2a. So compare this 2a and 2. What we could see, here it was minus I1 R3. Here, sorry, it would be I2. It was minus I1 R2. Here it would be plus I1 R2. And why it is coming? This minus sign get vanished and the other thing is same. You could see 2 and 2a. So this minus sign vanishes because direction of I1 what we had assumed, it is opposite. Okay. Now here also we are getting two current I1, I2. Now solving this two equation number from equation, let me eliminate this one because now you could actually mess up. From equation 1a and 2a, what we are going to get? We are getting to get I1 equal to some value and I2 equal to some value. So you could see that the current passing through RL is I2. So whatever value of I2 would be coming, that actually we are going to replace there, and we are going to get the answer. And that is what basically this KVL, and how I could apply this KVL in any particular electrical system. So hopefully it would be clarifying your fundamentals, and it would be helpful to solve the problems accordingly. And what I feel that whatever I discussed so far in this session and just previous session, it would be helpful for the person who are actually trying to get the basics right, and particularly the first year students who are having the basic electrical engineering. It would be helpful for you. So what my suggestion is, you could take any textbook, come across the problem with the concept what I had told here. If you have any doubt, you are free to contact me. Thank you. Have a nice day.